Now we go to our next speakers, who are Aurelio Muttoni and Joseph Schwartz, that I already told you a little bit about them before. And they will do a presentation also on conceptual design, and then just after that they will do a small presentation about this conceptual design symposium. Just after that we will have the discussion.
Thank you, David. We will do our presentation together. Joseph Schwartz is a professor at the Swiss Federal Institute of Technology, the German-speaking part in Zurich, and I'm professor at the same university, but the French-speaking part in Lausanne, and both we are part-time at the university, and both we have design offices, and we also work part-time in practice. So we will start our discussion based on some slides that we have already discussed the last year in the symposium in Madrid. This slide we have presented them and discussed them with my colleague Miguel Fernandez, and we had the impression that it was a good introduction for a discussion on conceptual design. So very often one thinks, well, just conceptual design is the most important part. Yes, of course, it's one of the most important parts in a design. It's mainly related to creativity, of course. And the question is always, is it possible to teach creativity? And the second question is it possible to learn creativity? And if we want to try to ask these questions, perhaps we can also try to answer another question, which is, how do you learn to ride a bike? Is it possible to teach riding a bike? Is it possible to, and how do you learn to ride a bike? And the answer is very simple: just by riding. And if you are learning to ride a bike, then you will improve by training. And this is also very important. It is not necessary to learn from the best. Of course, if you can learn from the best, perhaps it's better. In some cases it is better, but it's not necessarily necessary. And so it's what we call, in fact, learning by doing. And both we have studied together with Joseph several years ago, and we have done also several projects and several things together. And we had a big chance. In fact, we had a very good teacher in bridge design. I think it was one of the best of his generation, of course. And we had a big chance that already during the study, we were able to do some projects, and we have started learning to design during our studies, just seeing how designs have been done. And I think this was very useful for us. Of course, we are now trying to do the same with our students, doing together projects together with the students. So, and before we discuss this, and then we will later discuss two small projects that we have done, there are other questions that are also important to get into this discussion. For instance, what is a good project? What we call a good project? A good project, we think that it's a project which meets requirements all over the life of the structure, and of course also during the construction. The client specifications and users' experience are crucial, of course. The elegance and the site integration, to us, the site integration is also absolutely important when we talk about, even when we talk about structural design. The cost efficiency, this is a very important one. It is more difficult when you have to design something and you have too much money. It doesn't happen very often, but it is very important to, and it helps a lot if you need to find an efficient solution also in terms of cost. Durability, robustness, resilience, of course, are absolutely important aspects, and sustainability, of course. And when we talk about these requirements and to what extent we can find an optimum, some skills and wills are fundamental in designing structures. One needs to understand how a structure works. This is a very important topic. So we have started many years ago working together with Joseph, trying to understand how a structure works. And I think this was extremely useful for us. And when we have another point, when we have a design, it can always be improved. This is very important for us. Even when we are proud of it. But how is it possible to improve it? And is there a procedure? So a lot of open questions. Do we need all structural elements? Some of them can be removed or simplified. This is also very important. I think improving a structure means also removing and simplifying it in many cases. So a very good design very often is one of the most simple ones that we can imagine. And can we increase the efficiency? This is a question that we should ask us all over the process of designing. And we have learned that for answering these questions, of many of these questions, graphic statics and start-and-time models are extremely valuable tools. And with this respect, we had a good chance with Joseph. When we were PhD students, we started working on these topics. And this is a book that we have started writing in '85. You remember, Joseph, together with our PhD advisor at that time, Bruno Türlimann. Another big chance that we had an extremely good teacher and good scientist. So together with men, I think both were crucial in our education. And we have learned that it helps a lot in understanding very simple structures, like a simply supported beam in reinforced concrete. It helps understanding how it works just by investigating start-and-time models. And we have seen that graphic statics, it's possible to determine forces just doing some sketches. It helps a lot understanding how the structure works. I think this for us, Joseph, was absolutely crucial in our education and also in learning also to design structures. And then we have continued with this. This is in '96. I had a very nice experience because I started teaching in a faculty, in a university for architects, Accademia di Architettura in Mendrisio. And this was a very nice experience because I have seen that using these very simple tools based on graphic statics, it's also possible to teach to architects how a structure works. And I think, Joseph, you have done in the last 20 years the same experience as a teacher to architects in Zurich. I don't know if you want to add something to this.
Yes, perhaps you can show the next slide.
Well, this is a very nice example.
Hello, good afternoon, good morning to everybody. So for my part, this shows a little bit how we are introducing a simple way to show to students how cable works, perhaps coming back a little bit to the first presentation of our course with these cables, showing to the students how a cable works using graphic statics. The cable has the most simple element, but a very, very efficient and powerful element. And we gave to the students a very, very small amount of thin cables, and it was very difficult to produce a net-like structure in the way that they didn't fall down. And so they could learn what efficiency means on the one hand, but on the other hand, they could also very nicely learn to feel how a structure works, to feel how the internal forces are really floating at the interior of a structure. And we have the feeling that this is very, very important, bringing form and force together.
But we have to be aware that structural design is just a part of the task. So another very important task we have learned, listen to the client, work as a team with the architect, with the contractors. This is absolutely crucial in conceptual design. Try to understand all site implications. Some of them are constraints, but they are always help designing. And we always say that without constraints, it is very difficult to design. Try to understand what went well and could have been improved in your last project. It is the only manner to do your next project better. But be proud of your projects. This is very important also. Even if they were not perfect, we all know that our projects were not perfect, and now we have learned how to improve them. Projects are never perfect. And perhaps this is the most important thing that we can say, have pleasure. It is a so nice task to design structures. Do it yourself. Don't delegate it to a machine, to an algorithm, or to another kind of intelligence. So after this...
Absolutely, one short remark on this, or one small additional point I want to quickly mention. I think if we are speaking about team, for me it was very important to put this picture in. These people climbing a mountain, and they are climbing the mountain as a team. And if we are going with the design in a project, it's clear that all members of this team have different training. They are coming from different directions. And it's not often so easy to understand what they are really wanting to attend. And I think it's very, very important to open mind, to be open to the wishes of the architect, of the contractor, of everybody involved in the project. And I think it's very important also there to teach to the students that prejudices are not a good thing to work together and really have to be overcome. All these people have other goals in their mind in some way. And this thing, in this sense, it's very interesting to discuss about the question of the optimum Aurelio has already mentioned. I think it's also very important by going in a team that the optimum is not the sum of the optima of the different disciplines. That means it will always be a compromise, and also in this sense, it is always possible to improve the project, but it's very strongly dependent on the criteria that are fixed from the very beginning. And I think to be aware of this is very, very important to be successful in the development of a project.
We will now switch to not a presentation, but a discussion of two projects that we have done. The first one is a small bridge that I have designed some years ago in the Swiss Alps. And the second project is a residential building that Joseph has designed in Zurich. So very different situations. So the first one is a small bridge. I like very much designing small bridges. It's much easier because I think perhaps we have more freedom in designing small bridges. So about the site, it's very important to understand the site, as already Hugo Kors has said before. You see, we are here in the Swiss Alps. in the southern part of the Swiss Alps. This is in this valley here. Here the language is in Italian, but it is still Switzerland. And you see here a little bit better the situation. So this river, Verzasca River, and the task was to intervene on an existing stone bridge here, which crosses the river here exactly in this location here. So this gives an impression about the site. But as said before by Hugo Corres, Google Earth is not sufficient. So one has to go there to study in a detailed manner the site in order to understand all implications and all peculiarities of the site. This is absolutely crucial. And not only the site, but just go around. For instance, this valley here is well known because there are many stone bridges, very old ones. This, for instance, is a very nice one. It's a footbridge, in fact. The builders, many centuries ago, they took advantage of the presence of this block in the middle of the river. And you see, the result is just a two-span arch bridge. It's a very interesting bridge built centuries ago. There are many in this valley. There are many old bridges, mainly built in the 19th century. They are not so old, in fact, reproducing exactly the same system as the Roman bridges. So the Romans have started building this kind of bridges, very similar to this one, about 2,000 years ago. And you see here there are walls, there are side walls here, and very often there is, and there is not only, there is always this parapet here, which is not just a parapet. In fact, it belongs to the bridge. If you remove the parapet here, the bridge will look quite different, in fact. So this parapet belongs to the bridge. Unfortunately, in these bridges, in many of these bridges, in order to widening the road, this parapet here has been removed. And this is exactly what you see here in this bridge here that we have been asked to restore. So this was the situation that we found when we started this project here. So the vault was not in good shape, and the parapet here has been removed in order to widen the road. And the request by the client here was to do a restoration of the bridge, and in addition to increase again the width of the road. And this is not an easy task. And perhaps the owner, he had in mind other projects that have been done in a similar manner. For instance, not far away from this bridge here, you see, this has been restored, and then there is a new concrete deck, a concrete slab over the bridge. And I think this is not a good example. Not a good example at all. You see the parapet, of course, has been removed. And then this cantilever here, this is a big problem because you get this shadow here. And having this, the perception and the architectural quality of the bridge is completely destroyed. So I think this is really not a good example. And when we started working on this project here, well, this is the question is how to proceed in designing the renewal of such a bridge. And this is a very general question, in fact. We have bridges, we have roads which have been designed and built when to be used in this manner here. And nowadays, of course, the requirements are completely different. So many of these bridges, they don't fulfill this kind of requirements. And at the end, working on this, I came to the conclusion that perhaps the best approach was the same as been followed several times. If you have a bridge which doesn't fulfill anymore the requirement, well, the best one is that you build a new one here, and you keep the existing one for other purposes. This is also a very nice example in Ljubljana. This is a project almost 100 years ago by a well-known architect. And you see here, it is possible to build a new bridge besides the existing one, and the use will be completely different. This is, for instance, for cars and for traffic, and this is for pedestrians and bikes. I think the separation is perhaps in this case really the best solution that we can imagine. And this is what we have decided also for this bridge here. This is the existing stone bridge here. It is a very nice bridge here. And we have decided to keep it, to restore it, and to use it as a footbridge and for bikes. People can stay here, have a look on this very nice landscape here. And then here there is a new bridge for the road here. Here it is not interesting to just to stay and have a look on the landscape, because there are cars, they are too fast and so on. But here is a nice experience to be on this bridge here. So this was the first very important choice. Now, when we start designing the new bridge, of course, the site is very important, and there is another question also, which is also important. Can we be inspired by the existing bridge in designing the new one? So this is the existing bridge here. You see here again, there is a block here, but this is one block. There are not many in the middle of this river, and it took profit of the presence of this block here, and they have built the stone bridge just on this stone block here. So can we be inspired? Can we do the same? Well, not so easy. First of all, we don't have anymore the block where we need to build the new bridge here. And what about the system? We have two arches. Should we do the same? Should we also build a new arch? And this was my first idea. So the first idea was to say, okay, we have two existing arches with the block. Here now we need to build the bridge with a much larger span because we don't have the block anymore. And it makes no sense anymore to have a support in the middle. Also, the technology has changed in the last, and the possibilities have changed in the last 150 years. And my first idea was to say, okay, it is an arch. We will build again an arch, but with the best technique that we are able to do nowadays. And I remember at that time I spent quite a lot of time in trying to design a very slender steel arch with very slender elements here supporting the deck here. And working on this project here, at the end, I have invested quite a lot of time, but I was not proud of at all. Or let's say, it was a very nice project from a technical point of view. And it was also perhaps a very important project in order to understand what is wrong. What was wrong in this project here? First of all, this project here doesn't respect anymore the existing bridge. Having an arch beside, with a different geometry beside existing arches, it is not an advantage at all. And having several small elements here, you have to imagine that it has to be in the space. We have too many elements here, and the image will be getting complicated and complicated. So it's perhaps, as I said before, it's perhaps a good design from a technical point of view, but not from the point of view of conceptual design. And this is what what we mean in fact with conceptual design. But even in this case, doing this kind of projects, you learn what you don't need, what is wrong. For instance, the arch is a very efficient structure, but you can adapt, for instance, the arch so that it works more or less like an arch here, and then you can get a frame. For instance, a frame is very similar, has a very similar functioning as an arch. We have just larger eccentricities, and at the end, this was in fact what I decided to do. So I started from the arch, but then I tried to adapt the shape of the arch in order to respect better the bridge behind, the existing bridge behind. So in fact, as I said before, a frame is just an arch with higher eccentricities of the truss line. And you can adapt the frame in order to increase the visibility of the existing arch, and in order to have also less elements and to have a better respect of the existing structure. Then, of course, doing this kind of considerations, there are also a lot of technical considerations that we need to do. For instance, here we have a significant thrust force here, because it's still more or less like an arch. Here we have a very large force here that we need to be carried by a foundation here, and these slopes here in this kind of valleys here, that are quite unstable, because here we can have a lot of water, and which means that here it is very difficult to build a huge foundation here, and it was a big risk for the durability and for the robustness of such a bridge. And this was the next step. It was a technical consideration, but also related to a conceptual design. And I came to the conclusion that the best, in fact, the most stable zone here from a geotechnical point of view is this one here. And in order to optimize also the earthworks here, the best shape would be something like this here. It looks a little bit strange as a frame. Typically, in a frame, you have vertical elements here, but this is in fact much more efficient in terms of constructability, and also because you reduce the horizontal component of the reaction, which is also very good, which is also a good optimization in order to reduce the sensitivity to erosion. And this is the evolution of the project here. And now when we have this kind of structure here, again, was what we said before, in fact, strata and die models are extremely efficient in order to optimize the shape of such a structure here. This is a very simple strata and die model here that you can see here. It was very, very helpful in optimizing this shape here. And I always say it is important to optimize the shape, even if you don't see, even if it is under the earth, because at the end you feel it when you see the structure on the surface. I think that you feel, I'm really very much convinced that you feel what is under the earth. And this is this is also an important, this is also very important, an important issue. So optimizing the shape of the structure based on the function. But the flow forces at the end is not the only one criterion in order to optimize the structure. For instance, conceptual design is also very important. Let's say, for instance, in this case here, in terms of flow forces, it would be possible, you see here, here we have a tapered beam, with we have an element here, a strut with a variable depth. From a structural point of view, it would be perhaps also possible to do it like this. But if you do this, you can see here, if you do this, if you increase the thickness here and you reduce it here, your system will completely change here. In this case, we have a bridge with this strut here, which becomes more important here. And I think that if we do this, this element here will become more important. And this is not the idea of the project. The idea of the project is to have a simple new bridge respecting the old bridge behind it. So conceptual, and this is a typical issue of conceptual design. So it's not only a matter of optimization. If you do this, if you do it thicker here, I think it's much better. These are just elements clamped into these abutments here. And then you put over these elements here a deck which is as slender as possible. And this is a typical example of conceptual design. There is another issue related to conceptual design here. When you build a new bridge beside an existing one, well then, per definition, you create a space. Very often you have to think in terms of space. We always design a bridge sketching a cross-section, but when we sketch a cross-section, it is not a 2D issue, it is a 3D issue. Because this issue of the cross-section is related to a complex functioning, which is typically a 3D functioning, and it is related to the space around the bridge, under the bridge, and in this case, between the bridges here. In terms of space here, it was, in terms of requirement of the road, it was unfortunately not possible to increase the distance between the two bridges here. It was just not possible here because of the requirements of the road. But it is possible in designing the bridge to increase the space, in fact, under the bridge here between the two. And this is how, in fact, I came to this solution here, which is a minimum solution here. It is just a slab with a strong beam here. The eccentric actions will be carried by torsion of this beam here, and this explains the width, which is more than 1 meter. And this is, you see here, I think this picture can show it nicely. It increases the perception of the space between the two bridges, and you have the impression that the distance between the two bridges is larger than in reality. So this is a typical, again, this is a typical example of a conceptual design in a bridge. So there are many things that are very difficult to teach. You just learn them in designing bridges, and you just learn them, and something which is also very important, in observing existing bridges and try to understand why I like this bridge and why I don't like this bridge. Built by others, designed by others, these are also very interesting, very useful procedure in order to learn. So here are some pictures you see here. The new one besides the existing one. The existing one here we have restored here. I hope that in some years this new parapet here, which which are very similar to the old ones, will look similar to this wall here. This was the idea, to have a restored bridge like in the 19th century, and to have a new bridge which is a bridge of nowadays, but completely respectful with respect to the existing one. And this is also a picture which shows that the transparency is crucial in order to be able to see the existing one. Here, this slide here shows that having a strat here, it avoids having the difficulty on having more or less the same inclination. It looks similar, the inclination here, but of course it is not possible to have exactly the same inclination here. But what is the inclination of an arch? Well, it refers to the main part of the arch, which is here, and to have a tapered beam here. It also helps in avoiding this conflict of slopes between the strat and the wall and the arch. Here another picture which shows the existing one here and the new behind. And here again, you see here, if you have a variable depth here, this is very useful because you don't have a clear reference between the strat and the arch, which means that it is difficult to, the perception will be simpler because you don't have the conflict of slopes here. So here are the credits, of course. As always, you are never alone when you design a bridge. There was a young engineer who was very important in doing the calculations, and the calculations have shown that some elements needed to be improved to be adapted, and also the shape has slightly changed because as a consequence of the calculations. And this is a very nice way to learn designing bridge. If you do calculation, you see that you are things that need to be improved. This is also a way to learn designing. And this is my partner in that design office where we designed this bridge here. And here we have also an architect who helped us in these considerations with the parapet and so on, and also in designing the space between the two bridges. And here, just perhaps some considerations with respect to working with architects. And this is particularly valid for bridges. But during the last 3 decades, I've learned that one of the most fascinating activities of a structural engineer is to collaborate with architects and to contribute to their project discussing our structure. And this refers to buildings, in fact. And in buildings design, in some cases, the structure can become a source of inspiration for the architect's work and contribute to express an architectural concept. So we are contributing to the project by the architect. In bridge design, the process is similar, but the roles are usually reversed. I'm convinced that the structural engineering should be one of the most important components in designing bridges. For instance, in the bridge that I have shown, and also in many others that I have designed, architects were involved. Their contribution is not always easy to describe. In some cases, it was just a critical remark, a suggestion, or even a question in the crucial phase of the project. But even if the contribution can be defined as minor in terms of hours, of quantity of work. In some cases, just a remark, just a critical question is sufficient to have a significant impact on the final result. And this is the very nice things of working with architects. Very often, architects are very important to improve our designs, also in terms of structural design. So I think that the best is that we switch to the next part.
Okay, then I will go on with the second example. This is residential building in Forsterstrasse. We developed together with Christian Keretz, and as Aurelio already mentioned, it's a totally different situation. We are here in the city of Zurich, close to the forest. We are in this part, and what's important is that we are in a slope, and there is a very nice view on the lake, on the Zurich lake. Now, if you're looking at the situation at the site, we see that it's a very, very small site. It was goal to build there an apartment for 5 families, and we see this huge property here on the south. The lake is in the direction of south here, and you see these very high trees here that are blocking the view on the lake during summer and opening this view on the lake in fall and in winter. Now we see these 2 aspects. The first aspect is that we have this situation of openness and closeness on the one hand. On the other hand, we have this rather small site, and the idea was to develop a building, to develop a structure with interior spaces that seem to be bigger as they are in reality. Also, this we heard before, connection with the space between the 2 bridges, this effect of space, of generating space and influencing this by the structure seems to be a very, very easy way. And perhaps I want to start with this quote of the architect, of Christian Keretz, who says, "Architecture is for us an indissoluble unity of material, construction, structure, and technical installation. The meaning of all these elements is strongly related to their contribution to the definition of architectural spaces." From the moment we are speaking about architectural spaces, we are clearly going from 2D to 3D, what's not always so easy for civil engineers, but I think that from the point of view of flow of internal forces, it's very, very important to be trained in thinking in 3 dimensions and activating also the way of transfer of forces in 3 dimensions, as we have already seen today in all these different examples. Now we created a small grammar, a grammar of architecture, a grammar of structure, a grammar of space building, by using only walls and slabs, no columns, no other elements, and no structural elements in the facade, without eventually some exceptions. That were the rules we started with, and that was also the grammar with a very, very small amount of rules, a very small amount of tools. We really tried to push to the extreme. And now, from the point of view of static principles, as I already mentioned, it's a question of balancing walls, so that it's not necessary to put one wall upon the other directly in the ground floor, but the idea was to balance wall by putting one wall on the other one, so that they are only touching in one point if we are going from one floor to the next one. You see, this can be very easily done if they are geometrically balanced. The one is supporting the other one. Here the upper one is supporting the lower one by hanging the lower one on the upper one. Here you have a combination. You have a beam and you have one wall supporting the beam, the other one supporting in a way that the beam is hanging. Then in the next step, it's clearly that this must not be a straight line. It can also be a zigzag line. And then you can eliminate the material in between. If you have the slabs, it's clear that you can transfer the forces you need for equilibrium through the slabs. That means now we have this wall totally cantilevering, but it cannot fall down because it's brought back in equilibrium by the tensile force and the compression force in the slabs. And due to the deviations here, we have forces in the horizontal directions that have to be taken with another couple of walls being developed in the direction perpendicular to this direction. That means now we have the whole repertoire and we can start to play with this. And the big advantage is, as the walls are no longer placed one exactly on the other one, that it will be possible to have spans of the slab much bigger than the slabs between the walls in one floor, because the slab can as well be posed on a wall or it can hang on another wall. You see this very nicely in this picture, how these walls are interacting. You see also very nice that all the walls are in relation from the point of view of structural design, but they are also clearly in relation from the point of view of generating of space and from the point of view of architectural design. And so it was a very nice negotiation between Christian Keretz and me to develop this system in a way that as well the structural and the architectural goals were at the end fulfilled in the best possible way. You see here a model. Models are very important. We hear this already several times today. This was a 1 to 50 model produced by the architects in microconcrete. And you see here nicely how the system works. You see this cantilevering wall. You see the slab. This wall is behind. That means this part of the slab is hanging on this wall. Also here you have a similar situation. We have a very big space here. And this part of the slab is hanging on this wall. That means if as a civil engineer you are in this room or you are in this room, you cannot not easily understand how it's possible to have these very huge spans without understanding that the wall is really, slab is really hanging on this wall. There you see the final project. You see very nicely that we don't have any supporting elements in the facade without these separation walls. These are the separation walls between the different apartments, and on the one hand they are necessary from the point of view of use. On the other hand, they are also very nice to have something like a disturbing element in this clean situation of free facades. From the point of view of principle, it's easy. We see on the right-hand side these three stories. Two ones here are mirrored this axis. The upper one, Attica one, is a separate one. Then we have an in-between cellar story, and on the bottom we have a parking garage without any columns. And also there, at the beginning, the architect had 4 columns here, and these 4 columns is clear, they were situated here. And then for me, it was clear that we have to eliminate these columns, because if we are working only with walls and slabs, it would be a very nice challenge to have this parking garage with 25 meters to 15 meters without any columns. Also very nice that the building is floating here. You don't have any structural elements in the facade between the cellar story and the first story of the building. Here you see the principle, and one more coat. The same walls which are part of the introverted spaces at the interior of the apartment are leading to totally glazed open living spaces. This leads to antithetical qualities, cavern and pavilion, open and closed, heavy and light, to an indissoluble unity. These characteristics are in close mutual relation and are variable occurrences of the same unique spatial concept. A very clear concept allowing all these characteristics. You see it very nicely here at the interior. It seems to be something like a cavern. You feel very nicely how light is coming in, that there is open space on the other side. You can pass it, then you see it, and when you are going through this opening, you are coming to this totally open space, the one I mentioned before. You cannot understand how this can statically work if you are not understanding that there is this wall above your head supporting the slab. Here you see how we overcame the columns in the parking garage using this beam-like 3D system. With the deviatoric forces we will see of the pre-stressing tendons, it's possible to eliminate the columns here. The same in the other direction here, you see. And these deviatoric forces are replacing the columns so that it becomes possible to have this garage without any supporting elements. Here you see how it was solved on site, how these cables are as well placed into the slab and into the walls. Here a very nice sketch once more with stress fields, with strut and tie models. We have a very huge force coming down here. You see the forces in the force diagram around 5 meganewton. We have here a quarter of the load of the whole building coming down here. It's taken by this cable. You see very nicely how we solved it. Where it is a very nice sketch only in the plan. We find out here, for instance, the shear reinforcement we need to overcome here, to have enough shear resistance here to bring the very huge force of this wall into this wall here, as it was not possible to place the anchorage heads directly in the axis of the vertical wall. By a simple triangle, it was possible to find out the force and directly find out the reinforcement needed here. The same for a wall that was hanging, and one or the other walls are hanging. You see the situation here. We put also here pre-stressing cables in, pre-stressing tendons in, because here we have only 30 to 30 centimeters to have the whole tensile forces in the system. And you see very nicely comes from the lower wall is going in here, and the compression strut by developing something like a hidden column at the interior of the wall that was then built here. It's clear that all these considerations I have done till now in my presentation, the position of the different walls, the span of the slabs, all these things are dependent, and the aim was to have cantilevering slab elements with a maximum of 5 meters, and this was solved by pre-stressing tendons, as you see here, nicely developed in the way that dead load of the slabs was perfectly balanced by deviatoric forces of the cables. This is, of course, very important not to have problems with very expensive glass panels in the facade.
Perhaps, Joseph, if I may intervene, this example shows really very nicely that even if we do a composition of walls and slabs, which are 2D elements, in fact, but the composition is typically 3D. It's a space problem. And one has to, when one needs to have in mind that it is a 3D problem which is related to space and also to forces in the space.
Exactly. And it was then very important that we have always already seen with these concrete surfaces. The aim was to have very abstract surfaces, so we didn't put any anchorage heads in the outer in the outer elements, and so if cables were going through the whole building, we had to have two intermediate anchorage elements. We put them always in the situation of the walls, so that splitting of concrete was evitated, and on the other hand, these were only openings not going through the whole slab, but it was possible to have concrete beneath these openings so that it was totally hidden and abstract at the end. This I did 20 years ago, was already done by hand. The features were not so developed as today, but it worked very nicely, and correlation at the end was possible. You see here how it was done on site, and also if we are speaking about site, we helped to the contractor to develop this these formwork elements without any intermediate binding holes. So it was important for the architect to have these very, very abstract surfaces, and it was important also to understand from the point of view of conceptual design that all these elements, slabs, walls, conceptual development, realization on site, everything is connected, and it's not possible to do one step without thinking the other step. See very nicely how the aim was at the end reached, how the spaces are very abstract, how they are really seem to be bigger than they are in reality. You see also very nicely how the exterior is coming in the rooms. You see how the colors, the colors at the interior of the room is given by the color of the landscape. Here a little bit more the color of the snow. Here a little bit more the color of these green plants. And also here you can feel the strength of the structure. You can very nicely feel that at the end it was possible to realize a building where it's no longer possible to answer the question, what was first, the structure or the architectural idea? And Christian Keretz cannot answer this question. I cannot answer this question. They were developed really in the same time. They were developed as a team with a high respect, and also considering all the aspects of all people being involved till the last element was built on site. Thank you very much. Walls, strata, columns have in all our projects also a space generation function. It has to be determined in this context. In this sense, structural and the architectural concepts are merging and cannot be separated. That's it.
Okay, perhaps 2 words again about the symposium that we want to organize for 2021. So, Joseph, we're organizing this with also with Miguel Fernandez, Pierluigi D'Acunto, and Ole Olbrock. I think it's a nice team of experienced designers and young engineers. We want to attract designers and young engineers to our symposium. This is what we would like to we would like to meet people and to create an event on conceptual design. I really hope that it will be possible to do it physically. Otherwise, we need to do it again on web. But I hope that in 1 year, the problems that we have today will be almost solved. Or really, we all hope this. So. This is the location that we have in mind. It is in central Switzerland. It's quite easy to reach from Zurich or from Geneva airport. Switzerland is a small country. And perhaps the next slide. Yes, these are the most important dates. So the symposium will be 16 and 17 of September. And then which is a Thursday and a Friday. And then we will have also site visits. We will organize interesting site visits Saturday, 18th of September next year. Of course, it's a symposium. There will be presentations by many people. We will have very interesting people that we have invited to contribute to our symposium, but it is absolutely free, and everyone is welcome to participate. So, and the idea is that we will open soon the abstract submission, the most important dates you can see here on this slide here. So this will happen, in fact, the next weeks. And perhaps the next one. Yes, so this is a very important. I hope that you are interested in our symposium, and I think that I hope that it will be as successful as it was last year in Madrid. It was really a fantastic event, a fantastic experience, and we are working to have something similar next year. Please have a look on this website, and please contact us if you have any questions.
Thank you so much, Aurelio and Joseph. It was a very nice presentation,